Okay, so today we're going to be talking about real-world linear situations, basically. So these are situations that if I were to look at them and analyze them, they would produce some kind of linear expression if I were to graph it, basically. And these are the kind of things that you look at on a real-world level when we're talking about linear expressions. So, first things first, this situation. A bus has a 20-gallon gas tank. That seems like a really small gas tank, but what do I know? For every mile you drive, that bus uses 2 gallons of gas. So the first thing it asks is, what is the independent variable? So what is the x-axis representing? So how we set this up is the independent variable is going to be the variable that you are plugging stuff into. In this situation, that would be the miles that you're driving, right? Because that is what is independent. It's the gas that's dependent on how many miles you drive. So that would be the number of miles driven is what it represents. The dependent variable is the amount of gas. Amount of gas. Because again, if you don't drive any miles, you have the same amount of gas. The gas is dependent on how much miles or how many miles you drive. That's the difference between independent versus dependent. Okay, then it wants me to write a y equals mx plus b. That's the equation for a story, right? M is your slope. That's the rate in which things are going up or down. And b is your y-intercepts. That's like your starting point, right? That's where your line crosses the y-axis, but it's your starting point. Use m for miles driven and g for the amount of gas in the tank. So if gas is our dependent variable, right? That's the same as the y-axis. So it would be g is equal to, it's going to replace the y. And then, sorry. No, that's right, g. G equals, and then my slope. If I look at it, back up here, my gas tank holds 20, and I use 2 gallons of gas per mile. So this is the rate in which things are changing, is I'm losing 2 per mile, right? This is my starting point over here, 20. If I have a full tank of gas, I've got 20 gallons. Every mile I drive, I lose 2 gallons. So the slope for this would actually be -2, because I'd be losing 2 per mile. So -2 times the number of miles I go, plus 20, that's the number of gallons I start with, would determine how much gas I have, right? And if I go 0 miles, I would have 20 gallons. If I go 1 mile, -2 plus 20 would be 18. See how that works? So then it wants me to graph this equation, label my axes. So this would be G. This would be M, right? Gas and miles. And I start at 20 and goes 10, 12, 14, 6. I don't even have 20 on here. Well, it's a dumb graph. Let's say, well, let's see. Let's start at 16. So if I go 16, I would have driven 2 miles, right? So I would be 2 over here. So let's say I start right there. And then I'm going to go down 2 over 1 each mile I drive. Down 2 over 1, because each mile I drive, I'm losing 1 gallon of gas. And I went wrong somewhere because I'm ending at the wrong spots. Well, oh, I see the problem. That's 18. Shoot. I thought it was 16. It's hard to read that graph. Sorry, guys. So I was off by 1. So I'm rewriting these points because we make mistakes in math, right? Mistakes are not bad. They help us learn. We get a lot of brain growth from mistakes. There we go. And that would be the line that represents how much gas I have. Okay. That's what it's asking me to do. So then let's answer some questions about that graph. So on my graph, what is the y-intercept? So it's at 20, right? That's the full tank of gas. So 20. What does the y-intercept represent in the context of the story? That's the starting amount of gas, or the full gas tank, however you wanted to write that. On your graph, what is the x-intercept? Well, when I look at my graph, it's intercepting at, and I don't know if you can see it, number 10. So it's intercepting at 10 on the x-axis there. What does x-intercept represent in the context of the story? The miles you can drive until you run out of gas. Okay, on your graph, what is your slope? The slope was -2, right? What does your slope represent in context of the story? The rate in which you are losing gas. Okay. If the bus is traveling 9 miles, how much gas will be left in the tank? So let's look at that. So let's look at the equation I drew first of all. It's G equals -2m plus 20. M is miles, right? G is gas. So coming back over here, and I'm going to rewrite the equation, G equals -2m plus 20. If I know that I go 9 miles, I can remove that m for 9, and that will tell me how much gas is left in the tank, right? I could also look at the graph I just did, but let's do it in the equation. So if I plug in 9, I'd have G is equal to -2 times 9 plus 20. -2 times 9 is -18, plus 20 is going to equal 2. So I would have 2 gallons left in my tank. Okay? Not too tough, right? If the bus has 7 gallons left in the tank, how far have you traveled? So this is kind of the opposite. So it has 7 gallons left. That means that the G would be 7, and I'm trying to figure out how many miles. So this time I'm going to replace the G with 7 and solve for M. So it'd be 7 is equal to -2m plus 20. So it's just a 2-step equation, right? So the first thing I do is minus 20 to each side. That'd give me -13 is equal to -2m. Divide by -2. And I'm going to get positive 6.5 equals m. So that means I've driven 6.5 miles if I have 7 gallons left in my tank. And it's pretty much as hard as that. That's pretty much all you're doing today. Let's go through and do one more just to make sure you got it. There might be some quiz questions here, so kudos to those that are watching the video. I'll do this one because this is usually one that students struggle with. So, number 2. The population of Hurricane, Utah is 8,250 people in 2000. By 2008, the population increased to 13,322. So write a y equals mx plus b equation for the population hurricane. Use p for population and t for time in years. So first things first, I need to figure out what is the growth per year from 2000 to 2008. So what I'm going to do here is I'm going to figure out what the population change was. So I'm going to take my starting amount and subtract it from the amount after 2008. So 13,322 minus 8,250. So when I do that, 13,322 minus 8,250, I get 5,072. Now, still not quite there. That's my total growth over 8 years. I need to find a unit rate. So I'm going to divide that by 8, because 2008 is 8 years. Divide that by 8, and my slope is 634 over 1. So that's going to be my slope. So population is equal to my slope, 634, times the number of years, and then plus my y-intercept is my starting point, right? My starting point is what I initially had at 2000, which was 8,250. So 8,250. Those are my two numbers that I'm plugging into my equation. Okay. Then, if your population continues growing at its present rate, what will the population be in 2012? So 2012 is 12 years after 2000, right? So I would replace the t with 12 to figure out the population. So population would equal 634 times 12 plus 8,250. So 634 times 12 is 7,608. If you add that to 8,250, the population in 2012 should be 15,858. Okay? Assuming it's growing at a normal, consistent rate. That's the assumption with this problem, right? At its current rate of growth, approximately when will the population reach 20,000 people? So this time, I'm replacing the P with 20,000, because it's the population it's giving me this time. So 20,000 is equal to 634T plus 8250. So, again, two-step equation. I'd minus 8,250 first. So 20,000 minus 8250. I get 11,750 equals 634T. Then I divide by 634. Divide by 634. And I get 18.5. So T would equal 18.5, but it wants to round your answer to the nearest year. So 0.5, that means I round up. So T would equal approximately 19 years is when it would reach 20,000. Okay? And that's how you do it. If you have any questions, let us know. We're here to help. We want to help, and we'll see you out there, guys.